Hi Math, I'm Andy. Today, let's go to the calculus side and let's evaluate some definite integrals. So here's my situation. I have some function x squared minus 3. This is a parabola that has a vertex at 0, 3, and it curves upwards. I want to evaluate essentially the area under the curve from 1 to 2. So those are the vertical lines x equals 1 and the vertical line x equals 2. And we're going to use the x-axis as our other boundary. So the fundamental theorem of calculus is actually what we're going to use to help us out here. This says that if you want to integrate any definite integral from a to b of some function f of x dx, what you can do is take the antiderivative or the integral of f, we'll call that capital F, and then plug in the b value and take the antiderivative, we'll call that a capital F, and plug in the a value. And when you find the difference of those two functions, values, you'll get your definite integral value. So the first thing we need to do is integrate x squared minus 3. The integral of x squared, that's a power rule. That's going to give us x cubed over 3. Remember our power rule, the integral of anything x to the n is x to the n plus 1 over n plus 1. So that's how we're going to get x cubed over 3 minus, and then the integral of 3 will be 3x. And we're going to evaluate this from 1 to 2. And so what we'll do is notation-wise, we just kind of draw this bracket and we put our values of 1 and 2. Now, following this, we did our antiderivative. We're going to plug in the b and the a. So this is going to give me, and I'll use this, this is going to be 2 to the third power over 3 minus 3 times 2. So that's going to be the f of b, so to speak, minus, and I'm going to plug in a 1. So this is going to be 1 to the third power over 3 minus 3 times 1. So this is that difference, the difference of f of b minus f of a. So then we evaluate this. 2 to the third power, 2 times 2 times 2, that's 8 thirds, minus 3 times 2 is 6, minus 1 third minus 3. And I could evaluate this 8 thirds minus 6 minus 1 third minus 3. Ultimately, we end up with an answer of negative 2 thirds. And so the answer to the area under the curve of x squared minus 3 from 1 to 2 is equal to negative 2 thirds. Let's just continue. Let's look at another example just to kind of really solidify this idea. So let me kind of erase what I just did there. And let's take a look at another example. We're just going to evaluate the definite integral. And how about this? We'll do from 1 to 4 of 3 square root of x dx. So we'll just take the definite integral of this function 3 square roots x dx. Now our process really will be to rewrite this. Because 3 is a constant multiplier, I can pull it out of the integration idea, and the square root of x, I'd almost rather think of this as x to the 1/2 power dx, because then I can apply my power rule. So the power rule is we're going to add 1 to our exponent, so that's going to give us 3/2, and then we divide by 3/2 as well. And I still have this multiplier of 3 out here. And so I'm just going to have these 3's cancel each other out, and this 2 I'm going to multiply by 2 over 1 on top and bottom. So I'm going to get 2x to the 3/2, and I want to evaluate this from 1 to 4. So I'm just going to follow my fundamental theorem of calculus rule here, and I'm going to plug in a 4 and plug in a 1 and find the difference. So this is going to be 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. So 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. And then I just evaluate this. I know the square root of 4 is 2, and 2 to the third is 8, and 8 times 2 is 16. So I get a value of 16 here. 1 to the 3 halves is 1 times 2 is 2, and 16 take away 2 is equal to 14. So our answer up here, the integral from 1 to 4 of 3 square root of x dx is equal to 14.